Today we will do the nomenclature, system of naming. Okay. What is nomenclature? It is the system of assignment of names to organic compounds. And what is the need of nomenclature? The need is such a large number of compounds of varying molecular structure, varieties of molecular structure. And next is isomerism, another reason for the large number of compounds. So the need for correct and methodical and different naming to distinguish between the compound was found. So that is why to distinguish between the compounds, this naming was done. A correct, methodical and modern way of naming was done. Previously the system was a trivial system, a common naming system, and IUPAC name. This is the modern systematic naming. The previous naming, that is the common naming system, is based only on the source properties or the Latin names. Suppose marsh gas. Methane is called marsh gas. Why? Because the source is a marshy areas. Methane is found in marshy areas. Then the properties. Suppose acetic acid. Acetic acid has a sour taste. So acetum means sour. That is why acetic acid. So these are the source properties or the Latin or Greek name. Suppose formic acid. Formic acid is from Formosa or red ants. So the source as well as the Latin name was used. Now the actual IUPAC system or the modern systematic naming, it contains three things. The root word or the word root is the central part, and the suffix means after the word root, and the prefix before the word root. So we have the word root or the root word like this, and the suffix over here. Suffix is again a primary suffix and a secondary suffix, and then the prefix in front. Prefix, word root and suffix. First we start with the word root. What does the root word say? It indicates the number of carbon atoms in the linear chain. How many carbon atoms are present, and there is a name for it, like meth means C1. 2 carbons are present, eth. 3, then prop, but, pent, hex, hept, like that. Number of carbon atom is indicated by the root word. Next is the primary suffix. What does the primary suffix say? Primary suffix indicates the nature of the carbon bond. If it is a saturated compound with carbon-carbon single bond, then the ending is the word root, whatever may be according to the length of the carbon chain, and then the ending, that is the suffix, is ane, A-N-E. So suppose meth or say eth means 2 carbon and single, they are bonded singly, that is a single bond is present between the 2 carbon, then it is called ethane. Or say propane, 3 carbons are there, that is why prop, and ane means single bond. Then carbon-carbon double bond is indicated by E-N-E, ene. So propene, butene, that way. And a single 2 carbon atoms, when they are linked by a triple bond, then it is called yne, Y-N-E. So the word root, eth, meth, prop, not meth in case of yne, it has to be 2 carbon atom has to be the minimum. This is the first, means ethyne is the first member. So 2 carbon, it begins with ethyne, then can be propyne, can be butane, etc. So this is called the primary suffix, which is giving an idea of the saturation or unsaturation present in the compound. Next is a secondary suffix. Secondary suffix. This indicates a particular functional group. Remember, these are all position, number and type. All 3 are given by it. Okay, the position of the functional group, number of functional group and type of functional group. What are the types of functional group? Alcohol. Alcohol is OH. OH and all. It has, what is the secondary suffix used? All. What is the secondary suffix used for al? This is al, means aldehyde. For aldehyde, the functional group is CHO. The class of compound is aldehyde, the functional group is CHO, and what is the secondary suffix used? It is al, al. So, suppose you are writing an aldehyde with 3 carbon atoms. So propane, al. Prop is the word root, ane gives the primary suffix, and al gives you the functional group, the secondary suffix. Propane, al. Now E is removed and then the al is added. Or oic acid, COOH, this is for the carboxylic acid, oic acid. Now prefix, next part is prefix. The first thing that we name is the root word or the word root, and prefix comes before the root word, that is before the word root or the root word, and the prefix indicates the position, number and name of the substituent that is present. Means if branching has occurred, then the substituent ethyl, methyl or chloro, bromo, all these substituents are named by the prefix. The position, number and type of substituent is given by the prefix. Position, number and type of the substituent is given by the prefix. So we will now see the rules of, just now you just understand what are the rules. I am not writing it down. When we do online classes, we have contact with each other, then I am going to give it to you in a systematic order. Just now you just understand what are the rules. The first rule states the longest continuous chain. The longest continuous chain. First, longest carbon chain. Longest continuous carbon chain means, suppose I am just writing the skeleton, okay, CH3, CH2, CH, CH2, CH3, CH3. Suppose this is the compound. This is not the longest continuous chain. This is the longest. See, 1, 2, 3, 4 carbons only. Here there are 1, 2, 3, 4, 5 carbon. So which is the longest continuous chain? This. Longest continuous chain. Now, if the chain contains a functional group or an unsaturation, then the longest continuous chain must include that functional group or unsaturation. Suppose instead of CH3, it is CH2OH. CH2OH means along with this carbon atom has to be included in the chain. Longest continuous carbon chain, we will modify that then and write longest continuous carbon chain including the functional group or the unsaturation. There can be a double bond also. Here it can be, instead of this it can be C double bond CH3, CH2 or anything like that. So we are sticking to the first one only, CH2OH. So in that case this is the longest chain and this becomes a substituent. This is the branching, ethyl is the branching, okay, and this becomes the substituent. So first of all we select the longest continuous chain with the functional group, and this is 1, 2, 3, 4. Now the next rule says that if the numbering, the second thing that we have to do is numbering of carbon atoms. Okay, this is CH2 and this is the number. From where do we start numbering? We start numbering from, suppose this CH3, CH2 or CH, Cl, CH2, CH2, CH3. So what is the word root? It will be 1, 2, 3, 4, 5, means pent. Pent is the word root. And what is the suffix? All single bonds, so ane. Primary suffix. There is no functional group over here, so there won't be any secondary suffix. So it is pentane. And what is the substitution? What will you write for the substitution? It is chloro. Now how do you number the position of chloro? You can't number from here 1, 2, 3, 4, because if you are numbering from here, this is the 4th carbon, and if you start numbering from here, it is the 2nd carbon. So we will start numbering in such a way that the terminal end which is nearest to the substitution gets the smallest number. So this terminal end is nearest to the substitution, this gets 1, and substitution will get only 2 positions. So we write 2, this is 3, 4, 5, pentane. So 2, and then we put a hyphen and write chloropentane. Chloro, you may write it to, actually we should write it together. You may write it, you may leave a gap also, it doesn't matter. So 2 hyphen chloropentane. That is one of the rules. Now the next rule says that if the same substitution is taking place at 2, 3 different positions. Suppose there is a chloro over here. 1, 2, 3. Now how many carbons are there in this? 1, 2, 3, 4, 5, 6. There are 6 carbon atoms.